Welcome to Man Does Tech, where I solve the problems you didn't even know you had.
You start by reproducing the error reliably. Know the exact input, sequence, and environment that trigger status stack buffer overrun. Once reproducible, capture dmesc and the offending process core dump so you have evidence to inspect. Make sure to work in an isolated test environment, snapshot, or container so you can iterate without risking production. Now prepare debugging tools, GDB, utter2line, and symbol files. These let you map addresses to code and begin the root cause analysis. Next, run the failing binary with sanitizers enabled. Address sanitizer will often pinpoint the overflow site and show the offending buffer. If you cannot recompile, attach GDB to the crashing process and get a full backtrace. Examine saved return addresses and local buffer sizes to find overwritten regions. Once you have addresses, use utter2line or your symbol server to translate them into functions and lines. Then inspect code for unsafe functions or incorrect length calculations. Implement a targeted fix. Add explicit bounds checks, replace unsafe calls with size-aware APIs, or switch to dynamically sized buffers where appropriate. Once done, rerun unit tests and fuzz the problematic inputs to confirm the overflow is resolved and no new issues appear. If the crash persists, create a minimal reproducer and audit calling conventions and stack alignment. Sometimes compiler flags or mismatched frame pointers cause deceptive symptoms. One key troubleshooting tip: always compare builds with and without optimizations to spot optimization-induced corruption.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.